Alright, so here are the three ways to look at proving triangles similar. The first one, and I put the stars here because that's the most important one by far, this is the one that pops up the most, is angle-angle. And all you need with that are two angle pairs that are congruent. So like this angle is congruent to this angle, and this angle is congruent to this angle. That guarantees that these two triangles are similar to each other. Doesn't mean they're congruent, because they don't have to be the same size, but they will be generally the same shape, and that's kind of what similar means. The other way to do it, you could have side, 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 which are three side pairs in proportion. So you see here I have 3, 4, and 6, and then on the other triangle, not drawn to scale obviously, is 9, 12, and 18. And you know, the proportion here is just 3 times 3 gives you 9, 4 times 3 gives you 12, 6 times 3 gives you 18. Or if you go the other direction from here to here, that's a scale factor of 1/3. Either way, it's the same number for all of the sides. And then the last way is side angle side, where you have two pairs of sides that are in proportion, and the angle in between is congruent. So those are the three methods you can use to prove triangles similar. Okay, so what we're going to do here is we're actually going to prove some triangles similar, and these are the two most famous, really, similarity proofs that are out there. There's this one that I like to call the bow tie because, you know, it kind of looks like a bow tie if you turn it and move it around a little bit. And this one's like an A-frame, like one of those houses that's like a big triangle but with a beam going across the middle. So, yeah, let's start with the bow tie. All right, and the most important piece of information here is that TP is parallel to SR. So I'm going to put little arrows for TP and SR. So we know that TP is parallel to SR because it's given. Okay, great. Now, the important thing, what leads directly from this, the fact that these lines are parallel, is that it means the alternate interior angles are congruent to each other. So for example, angle R is congruent to angle T. You could also say that angle P is congruent to angle S, and then you have angle-angle. Or I'm going to use the vertical angles later, just full disclosure. So let's start with, let's pick angle T and angle R. Okay, now you see I have angle T is congruent to angle R because alternate interior angles are congruent when lines are parallel. Don't forget, label it on your diagram as well. Now, again, we could have just thrown it all together in one statement and mentioned P and S are congruent to each other for the same exact reason. Or the other option you can use is you can mention these vertical angles right here, which is what I'm going to do. So we have angle TQP is congruent to angle RQS. And that's just because vertical angles are always congruent. And now, if you look at it, we already have angle, angle. So right there, we have enough to say these triangles are similar. So it says triangle TQP is similar to triangle RQS by angle, angle. Simple, easy, not so bad. All right, with the A-frame, you can tell by the diagram here, these arrows, it says that VO is parallel to IE. So let's start with that. Okay, VO is parallel to IE because it's given. Now, the next step here, when we have these parallel lines, we may have forgotten about these, but they pop up again. This angle right here, so like angle V and angle DIE, those are corresponding angles. And as long as these lines right here are parallel, the corresponding angles have to be congruent. So you can use that angle and that angle, or if you want to, you could use this angle and this angle. I'll just pick these. You can honestly use both and do angle, angle, and then everything's fine. But I'm going to show you another trick that pops up with these two. So it says angle DIE is congruent to angle DVO. No, I don't have anything against the band Devo, and I do not want them to die. So these are just a diagram. Don't worry about it. Because corresponding angles are congruent when lines are parallel. Now, again, as mentioned, we could do DIE and DOV if we wanted to. I'm not gonna. Instead, I'm going to look right here. And one thing that's super important is looking at what two triangles we have to worry about. So we're looking at this triangle, triangle DIE, the little tiny guy, and we're also looking at the big triangle right here, or triangle rather, DVO. Now if you look at it, one thing you should notice is that right up here, angle D, they both share angle D. They both have this same angle in both of them. So what you can do is actually a nice little throwback to last unit. So we can say that angle D is congruent to itself because it's in both triangles. And that's just, again, as we did before, the reflexive property. So angle D congruent to angle D because of the reflexive property. And the reason we can do that is because both of these share the exact same angle. They both have all of angle D as part of their triangle. Like this little triangle includes angle D, and the big triangle includes angle D as well. All right, we're ready to end this thing. So let's end this thing. We have triangle DIE is, nope, not congruent, sorry about that. Just get in the habit, you know, is similar to triangle DVO by angle.